Hello everyone. Today we are going to solve the problem count leaves in binary tree. So in this question there is a given binary tree of size n. So we need to count the number of leaf nodes in it. So for example, in the given tree, the 1, 10, 39, 5, there are two leaf nodes which are 5 and 39. So in the first example, given tree is 4, 8, 10, 7, 5, 1, 3. So 3, 5, 1. These three are the leaf nodes. So the output is 3. So in this way, so they gave the time complexity is big of n, space is also big of n. So the companies are Samsung and Ola Caps. So how we can solve this problem? We are going to discuss the approach. So first we need to know that any one of the traversal technique of the trees. So we know there are almost most popular are four traversal techniques, which are pre-order, in-order, post-order, level order. So using any one of these four traversal approaches of the binary tree, we are going to solve this question. So how? So we use pre-order algorithm to traverse the entire tree. So what we know? So a leaf node is that which the so this is what it is called as a leaf node, in which the left child and the right child, the both are null. So that is called as a leaf node. So and we use a variable count to count the leaf nodes. So how we are going to do? So during the pre-order, what is the first node? It is 1. So once left or right child, these both are null or any value. So we can see there are 10 and 39 in this example. So the left and right childs are not null. So it is not leaf. So we go to the left subchild. So it is 10. So to the 10, left child is there, but right child is not there. But we should check that both child should be null. So it is also not leaf. So there is a left child. So you again move to the left. So to 5, both left and right child both are null. So it is a leaf node. So at here, what is the count? It will be 1. Next, for 5 left and right both are not there. So we go above 10. For 10 there is no right child. So we go again to the root node 1. So the left traversal is completed. So we move to the right. So right we have the 39 value. So 39 left and right childs both are null. So it is a leaf node. So count will be 2. So here also left and right both are not there. So we go again to the root node. So traversal is completed. So what is the output? Output is count, which is 2. So in this way we are going to solve this problem by using the pre-order algorithm to traverse the entire tree and simply maintaining a count variable to store the number of leaf nodes, and the leaf node definition is there here. So we said we use the pre-order logic, static, don't need static, void method, which is pre-order, and in the pre-order we send the root, and that's it. So if the root is null, we immediately return, because we don't need to have anything to do. So before this we said that we will maintain a variable count which starts from 0. So if left child is null and right child is also null, then obviously it is a leaf node. So we need to increment the count by 1. So what is the pre-order logic? Next, pre-order of, after the root nodes condition, we need to traverse to the left. So root dot left subtree. So after the left subtree, we need to move to the right subtree. So that's it. So every time we make the count is equal to 0 for safety purpose and error free algorithm. So we call the pre-order method using the node given as a root value. So it initializes the count to the respective leaf nodes count. So return the count. You can see sample test case is passed and the hidden test cases are also passed. We kept this value because we are using a static variable which is linked to class. So when one object is created, the count is initialized, but during the second call, the count remains the same count which was previous. So it will every time override and add to the all the sums from the different test cases. So it should not happen. Every test case counts should be independent. So every time I am making the count is equal to 0, so that every time the count will start as new as the beginning, and then the counting will be started of the leaf nodes. So if you see our code complexity, it visits each node one time, so it takes approx big O of n, and we just use a single variable. So I will write here time is big O of n, you can see. So space is, we use a single variable which is the count integer variable. It is a constant space, so big O of 1. So if you see the expected complexity is big O of n, so the time is matching, but they also used the space of big O of n, but our is only big O of 1. So our solution is more optimized in terms of space complexity. So this problem link is given in the description. So practice the problem. Thank you for watching.